Oh my goodness. All right, hello everyone. It's April the 9th. All right, I want to just do one problem today. Because believe it or not, I still haven't finished all my work for the day. Yeah, it's that type of day. All right, time needed to buy tickets. N people in a line queuing to buy tickets where the 0th person is at the front of the line and the n-1th person is at the back of the line. Wait, what was the problem yesterday? Sandwiches. I remember, it's the sandwiches. All right, again, n people in the line, 0 person is the front, -1 person in the back. You're given a 0 index integer array tickets of length n where the number of tickets that the ith person would like to buy. Each person takes exactly 1 second to buy a ticket. A person can only buy 1 ticket at a time and has to go back to the end of the line, which happens instantaneously, in order to buy more tickets. If a person does not have any tickets left to buy, the person will leave the line. Return the time taken for the person at position K to finish buying the ticket. So in this case, K is 0, 1, 2 is this person, right? So we need to take 1, and after you buy, you go to the end. 2, 3, 4, 5, 6. We could definitely simulate this. So we can do a solution with simulation, right? But probably there's a better way. Let's try to find a better way without simulating. So we can but remember, the person that gets 0 you will leave, right? So we scan through and scan through. So basically, it's a question of you have a list of numbers and you -1 at each time, right? And then the ones become 0, you don't count that anymore. And the question is for the kth value, right? For the kth, how much time does it take to get it down to 0, right? Can we have a easier way to do this? And we can definitely just go through this, all right, many times. We go once, right? And then we go 2 times. And then when it's 0, we just skip. Yeah, we can do that. We can do that. Okay, one run. I'm just still trying to see if there's a easier way for this, right? Define an easier way. Can we do, no matter where you are, right? No matter where you are, we can say we do 1 pass. We know 1 pass, how many is going to be, how much time it's going to take. But what if something becomes 0? Alright, so at the kth, right? So the kth, so I know at least I need 2 passes, right? I need 2 passes to get this. So I know, right? I need 2 passes. So at most, it's because 1 pass is 3, 2 passes is 6. So at most, right? So say at most, it would take 6 seconds, right? It would take 6 seconds. Now the question is, if some of this becomes 0 before this becomes 0, then those are extra times. Then we need to replenish, which means we can run it once, right? So we know we need 2 rounds. So I can go through every one, and any one of these become a negative value, right? Become negative value. That negative value will add up to this, right? So in this case, we have 5, 1, 1, 1. We know this is a 5, right? So we say at least we need to go 5 passes, right? We'll say at least 5 passes, right? So the basic time is going to be 5 times 4 equals 20. However, as we go through this becomes minus 4. This is minus 4. This is minus 4. Therefore, we have minus, I was going to say minus 16 and minus 12, right? Because all of these times are extra. So we have minus 12 extra time. So we do 20 plus minus 12, and the answer is 8. So with that, we can do just one pass. One pass. Okay, here is another idea. Here is another idea. We will add up everything because we know we have to do 5 passes, right? So we add up everything, and then we do a minus, right? So we add up everything, 5 plus 1 plus 1 plus 1. We know with the 5 passes, right? We know we have 5 passes, so we say 5 times 4. Right, we need 5 passes, and each pass will minus 4. So we do that, right? So this will give you what would this give you? This is 20 minus 8. Wait, hold a second. What are you trying to do? What I'm trying to do is right, this is 8 minus 20 is minus 12. So that minus 12 is what this one is. And then we do, yeah, so we run this to know how much extra time there will be. And then, okay, so here is my solution for this. Int total equal to 0, and then for t of tickets, total plus equal to t, and then we're gonna do t minus tickets k. So we're gonna do that many times, and each time we're gonna do tickets the length that many. So this minus this, and plus we need to do tickets k number of times, right? And each time is tickets length. So we return something like this. All right, so the total number at most is tickets k times tickets length. That's the total number of time it will take. But but we will have extra time. So that was the extra time. So if we put this together, isn't the answer is the answer just total? That's not right. Because if it's larger than 0, then we don't do it. Right? It's only when it's smaller, yes. So we say int total, int overcount. Okay? Call it overcount. So we're gonna do overcount as this. Okay, actually I'm gonna do minus total. That's the overcount. Right, this is the overcount. And the answer shall be overcount. Shall be minus math dot maximum 0 and overcount. $20.73. The max amount of time needed is tickets K times tickets dot length. Some people might finish their ticket earlier, thus they will produce and then not they will produce, thus we will overcount, right? Overcount them for time. The total amount of overcount is the sum, right, of tickets minus tickets K times tickets minus the sum of all the tickets. If there is positive overcount, we reduce it from the max count. Otherwise, we don't do anything. Okay, let's see how's this one going. Hope it's going well, so I can finish this and then go back to my work. Hopefully I can finish the work also fast. This is not right, dude. Did we at least get something right? Oh no, I think it's very wrong. 0, 1, 2, 3, 24. Okie dokie. This one's not right. What logic did we get wrong? 84, 49, 5, 24. Oh, I think I know why this. I'm overcounting. Should be 4, right? So it's 5, right? No. We're gonna go 5 rounds, but the last round, these don't count. So we go 4 rounds, right? 4 rounds. So 4 times 5. No. So we have the total, right? Then the over count. We try to find if there's any overcount. Actually, for this one, it doesn't really have overcount. So we're gonna go through this 4 times, so make this into 1. So we go 4 times 1, 2, 3, 4, 5, 6, 7, 8. So 4 times 8, 4 times, and plus the k is 3, right? It's here. Oh shoot, 0, 1, 2, 3. That's not 4 times, it's 23 times. So go through 23 times, and then plus 4. That's the total maximum, right? And then we need to try to find, so we have the total, then minus this, which means we have the total, right? And we need to say int max time shall equal to tickets k, right, times tickets k minus 1. So we don't go through all of them. This times tickets dot length plus k plus 1. Right, that is the max time, and overcount is max time minus total, right? If max time is small, then the total, I mean, whatever it is. Do we do the max time minus total though? Yeah, I don't think we should do max time minus total. I think we should be just going through them, you know, just going through them. I think add them together is not the right way to do it, because if you add them together, then the eventual thing you produce might not be a negative value, or it might not be a positive value. Like if you have a lot on one side, because you still overcut every single one, right? So what you should do is go through the first one, right, to count if any of the negative, if you put them together, right, and then you go another one all the way to k. Yeah, let's not do it this way. Let's not do it this way. This is not the right way. Yeah, let's just redo this. Okay, so get the first int overcount, right? Overcount. I know max time. I know max time is tickets k minus 1 times, all right, we probably need to use this a lot, so let's just do this, tickets dot length, right? So we do this times n plus k plus 1. That's the total max time. And overcount, okay, overcount is 0. And then we say for int tickets of tickets, right, we say if t minus tickets k minus 1 is, well, in this case should be plus 1, if this is smaller than 0, then we say overcount plus equal to t minus tickets k, right, plus 1. Then we do another round for int I equal to 0, I smaller equal to k, I plus plus, right? Ooh, we need to, oh, my bad. All right, this is completely wrong. Int I 0, I smaller than n, I plus plus. And we should say tickets I minus equal to tickets k minus 1. Then we say if tickets I is smaller than 0, then we'll plus equal to and then we go through this one more time. Then we say if tickets I is, because I'm -1, right? If it's smaller or equal to 0, then overcount plus. Actually, no, because it's negative. It should actually be minus. And at the end, we shall return max time plus overcount. Right. It is we first compute the max possible amount of time, right? Amount of time needed to reduce tickets k to 0. Then we go through all the tickets to find if there have been any overcount. And overcount happens, right, when tickets I is reduced to 0, but we continue decrement it on it. All right, so let's run this. Arguably a lot more reasonable than the last one. And in fact, we can take advantage of this. I feel this is very comprehensive. 6, 7. Okay. All right, let's run this and see if this one's right. This one's not right, and the second one is not right. And none of the other one is right. Okay, so we got wrong on the second one. 5, 1, 1, 1. Answer should be 8. I got 17. That is bizarre. What? 4 times 4 is 16. That's 17. Max time is 17. I have overcount, right? And then oh shoot, because I changed it. I cannot use ticket K. Damn it. Okay, I know. So it should be int I probably should do it here. Int K. Ticket K. Okay. Now I can use big K. Right, and then here is also big K. Alright, let's try this one. There we go. That is the right one. Oh, it took way longer than I had wanted. But at least we don't have to simulate. That was the ultimate goal, okay? Is to not simulate. No simulation. One pass. I mean, this count as 2 pass, right? I mean, I guess you can do this. You can do this, but all right. Anyway, that's it. I said I'm gonna do one, and I'm gonna do one, and I go back to my work. Hopefully, I can get it done in like maybe 10-20 minutes, and then we'll go to bed. All right, that will be it for today. I will see you guys tomorrow, and hopefully, I can start solving this problem. I think I have an idea of how to do this, but we'll do this tomorrow. All right, adios.